Hi, my name is Łukasz Langa.
And my name is Pablo Galindo.
And this is the Core.py podcast, a new podcast where we discuss internals of CPython and our adventures in making a new version of your favorite programming language. Today we have a special guest, Carl Meyer from Meta, to talk about how Cinder intersects with the evolution of Python 3. Hi Carl, very happy to have you here.
Hi, it's great to be here.
Before we begin, tell us a bit about yourself.
Yeah, I'm Carl. I've been working at Meta for 7.5 years now. Before that, I co-founded Oddbird, a Python application development consultancy, which is still going strong. And let's see, what else is there to tell? I was a Django core developer back in the day, and I'm now part of the Python team.
So you've been at Meta for quite a while now. Can you share a war story from your day job?
Sure. We were just chatting before we started recording about Python 3 upgrading. It's one of the first projects that I worked on. I joined Instagram in 2016, right before we kicked off the Python 3 upgrade. And one of my favorite bugs that I tracked down during the Python 3 upgrade was a test that was mysteriously failing inconsistently. It would fail every now and then. Most of the time it would pass. Couldn't figure out why it was failing. Eventually, I figured out that it was failing in the last 5 minutes of every hour. So if the minute hand on the clock was pointing to anything between 55 and 59, then the test would fail, and otherwise it would pass.
In what time zone?
Didn't matter the time zone. It's independent of the hour. It just has to be in the last 5 minutes of the hour. I guess there are half-hour time zones, so that would have... yeah, apparently somewhere deep in it was a test that was exercising a bunch of code. It was kind of like an end-to-end request test, so it wasn't clear what exactly was failing. But as it turned out, there was an algorithm, a bucketing algorithm, that was trying to place something into a bucket based on which 5 minutes of the hour it was in. And Python 3 had switched from integer division to float division.
Oh.
And so that meant that in the last 5 minutes of the hour, it would bump up into a non-existent bucket instead of being bucketed correctly.
Wow.
And of course, the test wasn't mocking out the time, so it was using the actual time.
Jeez, that sounds painful.
Yeah.
So these days, Instagram is running on Cinder, which is a fork of CPython. So like CPython, but not exactly. Can you share some of the changes that you made to CPython, why you made them, and how they worked out for you in production?
Sure. So I think there's two kind of headline features in Cinder. There's been a lot of small optimizations along the way here and there that we've made, and a lot of those we've tried to upstream. The two big features that aren't really feasible to upstream are the Cinder JIT, just-in-time compiler, and static Python. And those have both been fairly successful for Instagram. So the just-in-time compiler, it's written in C++. It's a fairly heavyweight JIT compiler in that it goes through several compilation stages with optimization passes. And let's see, what else is there to say about the Cinder JIT? So static Python then is a project to take type annotations, run a type check at compile time, and then make use of that type information in an expanded Python bytecode. And then the JIT can make use of that type information to make runtime execution more efficient. And that's also been quite effective for Instagram. For the right cases, the right micro benchmarks, static Python plus the JIT can be like 20 times faster, 25 times faster than CPython.
So that's static Python plus the JIT, right? Both at the same time, right?
That's static Python plus the JIT, yes. So static Python does things like it uses slots by default. So it looks through your class and figures out what attributes your type has, and then adds slots automatically. And then if static Python knows that it's working on one of these types that has these slots, then instead of emitting, for instance, a regular load adder, it will emit a load field, which is a static Python specific instruction.
Interesting.
Which knows the index of the slot that it's accessing. And so then when we put that into the JIT, it ends up compiling down to like literally one index load machine instruction.
Right.
So which is quite a bit faster than a typical Python attribute load because we can bypass all the dynamic machinery.
So it sounds like static Python is sort of like Cython for Cinder, only it doesn't require a specific DSL to function, right?
Right, exactly. I mean, I think maybe the closest parallel to it is MyPyC in terms of what it feels like to use it, because you're writing regular type annotated Python, and then with some additional strictness requirements, and then you end up getting Python-like performance. The main difference between MyPyC is that MyPyC compiles your Python module into a C file and then compiles the C file into an extension module. And one of the requirements that we had for Instagram, there was a desire to replace Cython. So Cython had been for a long time used in certain hot modules to speed them up. But this introduced a lot of extra complexity to the development environments because it introduces a build step, whereas otherwise Python doesn't really have one. So there was a desire to get rid of this build step and not have to have machinery to make sure that the Cython would always get recompiled at the right moments. And so static Python, the first thing that we did with it was remove all of the Cython and replace it with static Python. And we were able to do that with actually a little performance improvement relative to Cython.
Interesting, but does that mean that static Python compiles its code when the interpreter starts up in production, so for every machine?
So static Python, one of the design kind of goals of it was that it works, in terms of the developer flow, it works exactly like regular Python. So static Python has its own compiler, which is, we have kind of a base level compiler. It's actually interesting history here. Static Python is built on top of a Python bytecode compiler written in Python, which used to exist as the compiler module in Python 2.
Oh, in the standard library.
It was removed in Python 3, but then it was maintained as a separate open source project up to, I think, Python 3.5. Around that time frame, we adopted it, and we've kept it up to date and matching the upstream compiler through 3.6, 3.7, 3.8, now 3.10. So we have this baseline compiler written in Python that matches the CPython compiler, and then it's fairly extensible. So then we build static Python's compiler on top of that, where we run a type check over the AST, and then the compiler can make use of those types, and then in certain cases it can decide to emit different bytecode. So basically we have to install an import loader so that our compiler is used instead of the normal compiler.
Right.
And then you just get this expanded static Python bytecode, and then it just runs in the runtime, the Cinder runtime, the same way regular Python bytecode would run. So there's really no difference in the development experience.
Right. So as this podcast is heavily biased, as the three of us are core developers, I'm going to ask the stupid questions just to clarify. So I suppose that kind of a simplified way to think about the static Python is basically like a Python compiler that is doing the same thing as CPython, except that it's using all this static information and these extra constraints to produce more specialized bytecode.
That's right.
But it's not doing anything fancy like compiling native code or things like that. It's just a better bytecode creator, right?
Right, that's exactly right. So static Python is basically a compiler that creates special bytecode with extra type information in the bytecode. And then that works. So that can run just in Cinder's interpreter. And sometimes it can be a little faster, but we haven't really cared too much how much faster it is. But then where it really shines is if you combine that with the Cinder JIT compiler,
right,
which also knows about this type information in the bytecode and then can emit very fast machine code in those cases.
So how does the Cinder JIT compare to other JITs that we have for Python, like PyPy or Piston?
Yeah, that's a good question. I mean, it's obviously much less mature than the PyPy JIT, which has been around for a long time. The Cinder JIT was really built specifically for Instagram's use case, and that leads to some strange design decisions in a way. For instance, it only supports Linux x64 as a platform, so we don't bother supporting any other platform or architecture, which obviously makes it less generally useful, but that's all that Instagram or Meta needs.
The old trick is just caring about one case.
Yes, exactly. These are the reasons why I said earlier that this is not really something that we consider a candidate for upstreaming into CPython. The faster CPython team at Microsoft is doing great work on a tracing JIT with a very different design that makes a lot more sense for the general CPython use case. So Cinder JIT made different decisions. Another strange decision that was kind of driven by the Instagram use case is that it's much more difficult to do dynamic type profiling. And this is also one of the reasons that static Python made sense as an investment, because the Instagram web server is a forking web server.
Yeah, I remember that.
It starts up the application in one process, and then it forks a whole bunch of workers, like tens of worker processes. And then those worker processes are the ones that actually handle the requests. So you don't want to do JIT compilation in the worker processes, because then you would JIT compile the same function 20 or 30 times, which is like a big overhead, a big duplication of work. Mm-hmm. So you want to do your JIT compilation in the main process before you fork. But in that main process, you haven't really had a chance to observe the real workload in operation. You haven't been serving requests. And so you don't have that dynamic type information available to work from.
Right.
So it's still possible to do it. We could have tried to change the architecture around so that we have some kind of generational forking where the main process serves some requests and then forks. And that would have been a lot of re-architecture of the server. So what we ended up doing is first static Python, which can get some type information into the JIT in a static way instead of in a dynamic profiling way. And then we also have worked on type profiling, but it's a much more complicated system because you have to sort of profile in the workers, save the type information out into some kind of data store, then load it in the next time you restart the process and then compile using it. So it's kind of like a feedback loop. It's a lot more complicated to set up.
Right. I think if you if you think about like some minutes in the past when you mentioned that you the JIT is written in C++, you probably could hear a silent scream of all the Rust developers that are listening. So I suppose the next question that we have to make you is why did you choose C++ to make the JIT compiler?
I think expertise of people on the team at the time is probably, as is usually the case for a language choice, is like the high bit in that decision. I mean, obviously, C++ interacts very well with C, and CPython is written in C, so that part is not hard and provides a lot more conveniences than C does for writing big, complex projects. So I think those are the factors. I mean, if I were starting the Cinder JIT project today in a vacuum, I would probably think hard about Rust.
Right.
But at the time when we started, the people on the team knew C++.
Makes sense. So you mentioned that Cinder uses C++ for the JIT code, but is that true also for the other changes that it does? Like, so which ones are in C, which ones are in C++?
We have this one kind of funny little experimental project, which was interesting to do, but hasn't really found a fit in terms of kind of return on investment. It's called Strict Modules. And what it is like it's an analyzer for Python modules that effectively kind of, it has a little AST interpreter, and it is also written in C++, and it analyzes the module level code of your module and everything called from module level. So if you use a decorator or you make a function call at module level, it'll go and analyze that code also. And its purpose is to verify that your module has no visible external side effects at import time. Łukasz, you probably remember when you were at Facebook back in the day that we would often have problems with somebody writes a module over here that at import time, it makes some network request.
How could I forget?
Which in the first place, that's slow and unreliable. It could fail. But in the even worse case, maybe it's making a network request using some library that has to be initialized. And there's some other module over here that's doing that initialization at import time. And people write these two things, and it works because at the moment they write it, it so happens that the module doing the initialization is imported before the module making the network call, and that's all fine. And then later on, somebody adds some innocuous import in some module, and through a butterfly chain effect, 12 modules deep, it changes the import order of those two modules. And now you're trying to use this library before it's been initialized, and everything blows up. And so this problem of people doing things having side effects at import time that might interact with other side effects was something that we saw a lot and caused issues. So we tried the strict modules thing as like a comprehensive way to address that problem and ensure that a module does nothing at import time other than create some functions and classes internally. And we successfully achieved that. We have this tool that does it. And I'm on this tangent because that tool is also written in C++. The problem is that it turns out that for real Python code, like import side effects are endemic. They're everywhere. Everybody writes them. People write decorators that register things in other modules. And so to really be comprehensive about no import side effects turns out to be a very, very hard thing to get Python code authors to do.
Well, so that's too bad because that will allow us to have hot reloading during development, right? So just updating the module that the programmer is editing at the time they are editing it without having to restart the entire process, right?
Right.
I mean, we did actually write that also. We wrote hot reloading on top of strict modules. I mean, if you can imagine a world where you have an entire Python code base that all meets this strict module requirement of no import side effects, it unlocks all kinds of things. It unlocks safe hot reloading. It unlocks potentially much faster startup because you could think about freezing the result of module execution since it's idempotent and doesn't depend on external factors. and then you could have much faster startup potentially.
Yeah, it's what Emacs is doing.
Right.
So there's lots of things and also just generally static analysis becomes easier if you know that each module is independent. You can think about lazy imports, for instance. We could also discuss becomes suddenly safe if modules have no side affected import time. So there's lots of things that you can imagine would be very nice if you had this everywhere. The problem that we have is just that even the Python standard library doesn't meet this analysis, and getting all of the existing Python code and Python libraries in the world to pass this analysis is like boiling the ocean. And so far we haven't been able to boil the ocean. So strict modules remains kind of an interesting novelty that we haven't really been able to get great use out of.
I was going to say that I'm amazed how, especially when the number of people in the company grows to a certain size, all the problems converge to the same problem. Like, I thanks to the fact that this is just audio and people cannot see us, but I was just literally having word flashes from last week when literally we had the same problem at my company. Like, because we are just dropping a PTH file to track who is using Python, and that is using import lib to find the module when people run with -m, and that imports the module because that's how it works. It imports, like, if you have foo.bar.something, it imports all the things, and that changes the import order, and like all the party starts. So yeah, I'm amazed how everybody has the same problem, and all those solutions can be super useful if we could actually standardize something like that. But unfortunately, as Carl mentioned, it's quite hard.
Yep.
Well, because there are very many companies, but there is only one Stack Overflow.
Right. I think you mentioned these strict modules, which is quite interesting. And this is a tricky question. So strict modules, as you mentioned, they have quite a lot of advantages. And yet the static typing in Python is still a controversial topic, depending on who you ask. Even among some core developers of Python, they seem to be very strongly against it. For instance, Amir Ronaker recently wrote about how static typing is moving Python, in his opinion, in the wrong direction. What do you think about, like, the future of Python and typing? Like, should we do more typing to use these kind of optimizations and unblock them? I mean, obviously there's no right answer here, but we want to know your opinion.
Yeah, I mean, I think, as is often the case, how you view these things depends on your context and what problems you're facing. I think for people like our team who are dealing with very, very large code bases with a lot of developers working on them, things that move Python in the direction of more strictness, or at least restrict some of the dynamism, looks very attractive in that context, because you have massive coordination problems, and so you can't rely on people sort of knowing what they're doing in the same sense, because the code base is so big,
right,
and the number of developers is so big. People are very frequently making changes to code that they have no clue about. And I wouldn't claim that that's a great situation to be in or the ideal way to write software necessarily, but it is a fact of life for a lot of actual Python code bases and teams. So I think it's good that Python offers the possibility to write code in a stricter way with static typing for the situations where that makes sense. I'm not somebody who would say, okay, we should generalize from my team's experience to the entire world of Python users. I think Python is a great language for a lot of different use cases, and it should still be possible to write scripts and glue code and fun little super dynamic projects and not use static typing if you don't want to. So yeah, I guess I'm in the camp of hoping that Python can continue to serve all of these use cases with well-chosen compromises.
Right. So that means Cinder is very much aligned with what a big team working on a huge code base like Instagram needs. CPython is somewhat different here, that it tries to cater to all sorts of use cases there. So there is some sort of tension between the two. There's been some attempts to upstream changes from Cinder, for example, the lazy imports PEP, that's PEP 690, which was sadly rejected by the steering council. So what do you think about upstreaming other changes from Cinder to CPython? Is that your plan? Do you want to adopt things that happen in CPython instead? Like, what are you planning to do?
Yeah, it's a mix of all of the above. And I should say that lazy imports is in a certain sense an outlier. So let me give a bit of history here about Cinder. So Cinder started in 2017 as a fork of CPython, and we did all of these things as a fork of CPython, just sort of willy-nilly, patching whatever we felt like patching in CPython, and in order to get the results for Instagram as quickly as we could. And that worked fine for a few years until like upgrading from 3.7 to 3.8 was sort of painful. First we upgraded 3.6 to 3.7, that was okay. Then 3.7 to 3.8 was painful. Then we did 3.8 to 3.10, and that was super painful. It was like, I think we estimate like 8 engineer years of work.
I wonder what happened.
I mean, there's various factors there. One factor is simply the number of patches we had accumulated in Cinder kept increasing with each release. So we always had more patches to rebase. And then also, the faster CPython team started their work, which is great work, but it started to result in a lot more churn and changes to areas of Python that had been stable for a very long time. So that also meant that we had more work to do when upgrading Cinder. So those combinations of features kind of convinced us around 2020, 2021 that maintaining Cinder as a CPython fork was not feasible. It was just going to be like an ever-increasing, unbounded amount of work to keep up to date. So one option, of course, is we could just fork the language, sort of like Facebook did with PHP and Hack, and say, okay, we're going to go our separate ways. Cinder and Python will be different languages. We'll never upgrade again. But that's really, that was something you could consider for about 5 seconds and then throw out, because like everyone else, we use tons and tons of open source third-party libraries. Mm-hmm. And so to just give up on the entire Python ecosystem outside of the company would be a huge strategic mistake. So that's something we discarded as an option. We have to stay in sync with the larger Python community. So then it became a matter of, if we can't maintain a fork and stay up to date, and we have to stay up to date, then we have to stop maintaining a fork, or at least maintain a much smaller fork. And so that kicked off a lot of work to try to upstream Cinder features or figure out how we could extract them into an extension module. So it's case by case. So like one thing we had in Cinder is shadow code, which is like bytecode specialization or bytecode quickening, where you dynamically replace Python bytecodes with specialized versions, which is basically the same thing that the CPython does now in the specializing adaptive interpreter. So we're essentially abandoning shadow code because upstream has something that does the same thing and is just as good or better.
So are you moving to PEP 6.5?
So with our upcoming upgrade from 3.10 to 3.12, we will be abandoning shadow code and taking the 3.12 specializing interpreter as it stands. Mm-hmm. So there's some things in Cinder that we've decided to abandon in favor of upstream alternatives. Some things, many things we've successfully upstreamed. So we have a lot of sort of standalone little optimizations here and there. Some of the bigger ones were comprehension inlining, which I wrote a PEP 709, and that was accepted, and that went into Python 3.12. So that's one thing from Cinder that we successfully upstreamed. Also, some optimizations around super.
Maybe you can describe that
Sure.
briefly for people that don't know what it is.
So comprehensions, list, dictionary, and set comprehensions, historically, or actually not always, but for most of Python 3 at least, the way that those have worked is that when you write a comprehension, like x for x in some list, it compiles it to a little function internally, and then every time that comprehension is run, it calls a function.
Yes.
And it's actually like a nested function, which means that Python, there's a code object that's compiled once in the bytecode, but then every time that comprehension is hit when you're running your code, a new function object is created with that code object. It's called once, and then the function object is thrown away. So there's a fair amount of wasted work going on there. Every single time you run a comprehension, you're allocating a new function, running it exactly one time, and then throwing it away. So the idea behind PEP 709 was we don't have to do this as a function, a nested function. The reason it's done that way is because it provides very clean kind of isolation. So the iteration variable in your comprehension doesn't leak out to the surrounding code. It doesn't stomp on any values in the surrounding code. It's all like neatly isolated in a little package, but we pay a pretty high performance cost for that. So PEP 709 instead just does some more complicated, jumps through some hoops in the bytecode to ensure that we still isolate the variable names by like pushing things onto the stack and clearing them and doing all the right things carefully to make sure that the variable names stay isolated. But the comprehension is just part of the bytecode of the function it occurs in. It's no longer a separate nested function. And this results in in the best case, a comprehension that doesn't do very much will run like twice as fast. If there's more actual work in the comprehension, then the percentage improvement is less, but it's a pretty significant gain.
If I recall correctly, there was some funny case when we couldn't do the trick, right? Like some weird edge case in class bodies or something like that. I don't know.
I would say overall that there were more unexpected edge cases in PEP 709 than I expected. I guess that's the definition of unexpected. But a lot of things that we hadn't run into internally just because the case didn't happen to occur in any code at Meta, but that we did find. So there's so the way class body scoping works in Python is just weird to begin with, right? Like if you have a variable, a class level variable, then because you don't want methods to be able to see that variable directly, like the scope inside methods just skips over the class namespace and looks straight to the globals. So like, if you have like class C and then within the class you have x equals 1, then you have a method, it won't be able to see x. So that makes sense for methods. But that also, because comprehensions were compiled as nested functions, essentially a comprehension in the body of a class was like a method. So if you have like a class C and then x equals 1, and then like a comprehension that tries to use x, it actually can't. It can't see x because the comprehension is like a function. Mm-hmm. And so it skips over the class namespace and can't see that variable. And so the first version of comprehension inlining, it made it so that comprehension could see x, which I think a lot of people find more intuitive, but it is a change in the behavior.
Right.
So we do still actually inline in that case. It's just I had to make some adjustments
Pretty cool.
to the implementation so that we maintain the previous behavior of not being able to see those names.
So how is the pre-existing behavior beneficial to the user?
I mean, personally, I would say it isn't really. Like I don't think most users think of a comprehension as a nested function or as a method.
Right.
And so I think it's more intuitive for the user if a comprehension in a class body can see other names defined in that class body's namespace. But the issue is just that this came up fairly late in the 3.12 cycle after the PEP had already been accepted without highlighting this. And I think people felt reasonably that it was just too big of a change to semantics.
Yeah, someone somewhere in a dark corner is going to be using the fact that, comprehensions cannot see X, and that's
right, exactly.
Someone will bring the torches.
It could potentially change the meaning of someone's code. If you have a global X and then an X in the class namespace and then a comprehension using X, previously it would use the global one and now it would change to using the one in the class namespace.
Yeah.
And this could, in theory, break somebody's code. So, I mean, it's certainly something that we could decide to change in the future. It was just something that we didn't want to do accidentally at the last minute in Python 3.12.
Right. So the reason I asked was that I actually had an issue with the class scope with a comprehension that tried to address something in the class body.
So it was you. You are the person in the dark corner, in the dark room.
I mean, yes, but all I wanted was to have an enum that is embedded in a class and then to have a comprehension that addresses this enum so I could do some reverse mapping there. But I couldn't because it's invisible, which I find very unintuitive.
Well, if you write the PEP to change that behavior, I will happily do the PR to implement it. So,
but Luca, you need to think about this poor person that's going to run this test, and the test is going to be very flaky in the last 5 minutes just because the comprehension variable is not pulling the time zone or something.
Yeah, we'll deal with that issue right after we get the static Python PEP accepted. And joking aside, is this something that you depend on so heavily that you're going to keep rebasing Cinder over newer versions of CPython to keep this functionality?
Instagram does depend on it now. Static Python and the JIT fall into the category of things that we aim to extract and no longer maintain as patches on top of CPython, but rather as a third-party extension. Because the core of static Python is just a compiler that's installed via an import loader, and there's no need for that to be a patch. What's a little trickier is that it also introduces new bytecode instructions, and the interpreter has to understand those. So currently the main project that I'm working on for the last few months is pulling the JIT and static Python out of CPython and into an extension module that we're calling CinderX for Cinder as an extension. And the main trick there is that CinderX as an extension module will have to have its own separate interpreter loop, which is not a common thing for Python extension modules to have.
A new case for PEP, whatever.
PEP 523.
Exactly.
So we may use PEP 523, although we have to figure out, we don't want to lose the call inlining in the interpreter loop that that Python 3.12 does. So we have to figure that out. But yeah, so we'll have our own interpreter loop and we'll install it in some way, and Cinder will run that way. So
you mean the inlining of Python?
Yeah. So where you have a Python to Python function call, it just stays in the same interpreter.
That's 311.
Sets up the new frame and jumps to the top of the interpreter loop instead of making a reentrant C call.
Right.
And right now you lose that entirely if you use the PEP 523 frame evaluation API.
So I noticed that you were active on discussions that were around the executor API, so the new specializer plugin that is used by the tier 1, tier 2 interpreters. So is this going to be a replacement for PEP 523 for you?
Maybe. That's an area for further exploration that we haven't really had a chance to look into deeply yet. Like, those APIs were designed around the faster CPython team's idea of a tracing JIT design. So where you JIT compile traces of code that may not correspond to a single function, whereas the Cinder JIT is a method at a time JIT, where we take an entire function or method and compile that. So the design is a little different. So I did engage some with that PR to try to think ahead about whether this could be something that we would use for Cinder JIT in the future. And so I'm hoping that it might be, but that's still pretty hypothetical.
Sure.
One thing that like Cinder is using is the idea of immortal instances, right? And there was a PEP in CPython, particularly PEP 659.
683.
That, if I recall correctly, someone from the Cinder team, Eddie
Elizondo, yeah, 683, I think it is.
Elizondo, yeah, participated there. So is this the same technology, or like is Cinder using some different version of immortal instances?
So that did come from Cinder, and again, that's one of those things that originated with Instagram's forking web server workload, where if you are forking a bunch of processes and you're not re-execing a new program in after you fork, you can share memory between the original process and the worker processes because of the copy on write behavior. So if you don't change some piece of memory in the worker process, then it won't have to have its own copy of it. It can just share the one from the process it was forked from. And so one of the things we observed is that all of this reference counting, even if you don't change a Python object, if you just touch it in any way or use it or reference it, that's going to result in changes to its reference count. So that counts as a change to it. And so then it gets copied into the worker process's memory instead of being able to share it. And so that was costing us a lot of memory. And so immortal objects grew out of that situation where we wanted to say, okay, for the objects that exist in the main process before we fork, they'll probably exist until the whole server is shut down. We want all of those to be immortal, and we want reference counting to not touch them at all. And so we built a feature where we could make them immortal. And initially, when we tried to upstream that, I think we started trying like 4 or 5 years ago already. There was a lot of resistance because it introduces overhead for every ref count operation in order to check whether the object is immortal or not. And so it actually is a slowdown.
And that code base is very hot
for your single-threaded performance. But it's very helpful if you're in this forking situation. But reasonably, there was a lot of resistance because most Python users aren't doing this forking thing.
Yeah, but we did manage to upstream gc.freeze, right?
We did get GC freeze. That was an easier sell because there's not really any overhead. In fact, it just helps everyone. If you tell the GC, the garbage collector, to ignore a bunch of objects, that doesn't cause any slowdown. It just means your garbage collection is faster. So that was easier.
It's an
to
API
upstream.
that you can throw in some dark corner.
I mean, and also because it's totally opt-in. Like if you don't call gc.freeze, you're not going to freeze any objects, and everything behaves the same way it always did. So that was easy to upstream. We got that in. Immortal objects was harder, but Eddie just did a ton of work over the last number of years to, first of all, find different approaches so that the overhead to reference counting operations is much lower. Just some really crazy tricks that I won't try to explain here. You can go look at the code using like saturating reference counts and all kinds of fun stuff. But basically the point being that you make the overhead less. And then also, I think Eddie kind of found some interest from a different use case, which is the idea of multiple sub-interpreters, maybe having separate GIL so they can run simultaneously. And maybe you want to be able to share Python objects between sub-interpreters. And that's very hard to do if both sub-interpreters are independently trying to adjust the reference counts of the same object and they may be colliding and having races. So the idea of immortal objects kind of gained new life with this idea that it could allow for object sharing. If you can make objects really immutable, even the reference counts, then you can share them between multiple Python interpreters running simultaneously. So I think those two factors, reducing the overhead and finding this other use case that isn't quite as unique to forking web servers, opened the door to get that into Python, and we did in 3.12.
Right, very cool. One other feature that I find very useful for the general Python user, even if it seems a little bit esoteric, is await-aware function calls. This is something that Cinder implements, and it originates from a need inside the Instagram server codebase. So can you talk a little bit about that and how we might or already have a part of this in CPython?
Yes, that's a very interesting story. So I'll describe the feature a little bit. Like many interesting Cinder features, I should acknowledge this was written by Vladimir Matveyev, who works at Instagram and is super smart and figured out a lot of these things. So await-aware function calls, the idea is that in Python, you have async functions, right? So async def foo. And when you call foo, it doesn't return a result, it just returns a coroutine object. And then that coroutine object doesn't really do anything until you await it. So at some point, you await it. But typically, in the common case, you don't delay that. You just do await foo. So you await it immediately when it's called. And so if you're in that situation where the coroutine from the async function is immediately being awaited, then you can safely, without changing semantics, you can be a little more streamlined or a little more eager. You can just start executing the async function right away and see if it blocks or if it awaits on something else that blocks. Or maybe it doesn't block. Maybe it has a cache or memoization or something, and it can return a result right away. And in that case, you maybe don't have to create a coroutine object at all, and you don't have to create a task if you're in an async IO event loop situation. So you can avoid a lot of overhead. So what Vlad did is added to the Cinder interpreter a mechanism so that whenever we call an async function, we check in the bytecode, is this function about to immediately be awaited when it returns? And if so, we pass an extra flag to the function telling it that you're about to be immediately awaited. And in that case, it can eagerly execute and potentially even eagerly return a result without a lot of overhead. So that was a big improvement for Instagram, which is heavily async. I think it was like 5%, which is a massive improvement. And we did look at upstreaming it. The thing that we found was when we added some async benchmarks to the PyPerformance benchmark suite to try to replicate this scenario of a very heavily async workload with a lot of like nested async function calls and whatnot. And then when we actually explored the effects of different changes on those benchmarks, what we found is that we could get a lot of the wins just by avoiding scheduling a task to the event loop. Even if you don't do the whole awaited call flag and you don't do like avoiding the creation of the coroutine, but all you do is just execute the task eagerly. Mm-hmm. And if it returns a result eagerly, don't schedule it to the async IO event loop. So a much smaller, less invasive change we found was able to get a large percentage of the performance improvements. So that's what we ended up upstreaming.
Oh, so that's already upstream?
Because
yes.
It's in 3.12. It's called, you can find it in the 3.12 What's New. It's called Eager Task Factories.
Yes.
So the way it works is it doesn't really touch the language at all. Unlike the awaited call feature, it doesn't touch the interpreter, it doesn't touch the language. It's just a purely async IO library feature where you just set a flag or set a task factory. You tell async IO that you want to use these eager tasks. And then if so, async IO will eagerly execute your coroutines. And if they don't block, it will never schedule them to the event loop. So it's opt-in because it can change the order that your tasks execute. So it does potentially change the behavior of your program a little bit, but it can be significantly more efficient. So we did that. There's still an open question. It won't be until we upgrade Instagram to 3.12 and try to use this that we'll really find out for sure how, like on a very large real-world workload like Instagram, does this eager task feature provide as much benefit as the full awaited call feature? And if it doesn't, then we may go back to trying to upstream awaited call. I think Mark Shannon from Faster CPython wasn't super excited about awaited call because of the complexity it introduces. And the idea is that a future tracing JIT should be able to eliminate that same overhead by tracing through the async function call. So I guess Faster CPython has a little bit of a different vision about how to address that overhead.
Right. So I'm seeing here in my imaginary podcast dashboard that the controversy levels are very low. So we need to bump them up I want you to ask you, like, imagine that you have, something that you don't really like about Python, maybe some pet peeve or something that you would like to change. So if you have the magic powers of the steering council, I'm in the steering council, so I can give it to you virtually. I'm allowed this in the constitution, so 100% real. So what will you change, or what aspect of Python kind of irks you a bit, or kind of like you would like to see differently?
Yeah, I think I'll go back to strict modules and say that, like, I think the fact that imports are arbitrary code execution, and yet the syntax of the language and the way people think about them doesn't encourage people to think about them as arbitrary code execution is a problem. I won't really claim that it's the biggest problem. It's kind of just like a pet peeve because it's caused me a lot of problems. But I think I'll name that one as my the thing that irks me about Python.
Right.
It's a tricky problem to solve because I like the fact that you can do things like decorators, which run at import time. So I don't have a clear proposal of how it should be fixed. I have some ideas, but that's maybe the thing I'll name as my pet peeve.
I had a mini heart attack because I thought you were going to say, I like the fact that you can do network calls and import time. I was going to say, like,
no, that's what I don't like.
You are in the dark side. No.
So wait.
Controversy.
Well, we already know Carl's pet peeve, but what irks you about Python, Pablo?
As a steering council member, I'm not allowed to mention what is my pet peeve, but I'm going to say here in the podcast, in front of all listening, but my pet peeve is, and then yeah, so that's it.
I think you just don't want to name a pet peeve because you're currently running for the next steering council and don't want to alienate any constituencies.
Yeah, but it's only one day. We are recording on Saturday. The voting had already been done. I mean, people, I suppose they can change votes tomorrow, but the podcast doesn't air until probably next week, so I'm totally safe. I can say here that...
So you're safe. You can say whatever you want.
No, I mean, look, this is going to sound very cheesy, but let me at least say my closest pet peeve, in the sense that this is the thing that caused me the most pain in the last week, is precisely this import thing. Yeah. Because, like, chasing this down, actually, I'm going to be short here, but the actual way this manifested in some user code is that enums were not comparing equal to themselves. Wow. So you have red equals red, or red is red, like, color.red is color.red, and it was false. And the reason being that like Python, if you import an extension module, it DL opens the extension, but then it doesn't DL close the extension. So you load it again, it gives you the same thing back. So you pop a module from sys modules and then you try to import it again, it's going to give you the previous one, right? But it reloads the entire module, so all the classes are different except that the ones that are in the extension module. Mm-hmm. So tracking that stupid thing down, because the user is not telling you, oh look, you are changing my import order, how evil person. No, they are telling you, look, red is not red.
Yes.
And you're like, what are you talking about? and like, exactly. And also you forgot that you have this PTH file, like, lying around that is doing all this magic. So so you're like, no man, like, red is clearly red. Like, even I'm colorblind. I can tell you that, right? And then you start like pulling the thread down, and it's just...
No, we've had similar situations. It's also very dangerous. We've had people try to do things where you start catching import error and then having the program continue. And what people don't realize, that catching import error and not quitting the program is very dangerous in Python, because somewhere in the execution that resulted in that import error, you may have imported a bunch of modules. They created a bunch of classes and functions and enums and whatever have you. And then it's possible, because of import side effects and all the things you can do at import time in Python, that some of those things that were created were registered or otherwise, like, something held on to a reference to them, something somewhere else in your program. And then you have an import error.
Yes.
And then all of those imports are rolled back. The modules are removed from sys.modules. It's as if it never happened, right? And you come back, you catch the import error, and then you keep running your program. And then later you maybe re-import those same modules without the import error, and you have a new copy of all of those classes and functions and whatever. But somewhere in your program, there's still a reference to one of the old ones from the failed import. And so then you get into that same situation where people start to get errors that's like, red is not red, because you have two different reds in your program. So it's very, very bad.
Right. A bunch of APIs in the standard library depend on this sort of registration,
right,
like single dispatch and ABCs.
Wow. It looks like we are all traumatized. This is what holds us together as core developers. We are all so traumatized that we go to cry to the same place. Maybe at least someone not.
Yes, this podcast is a safe space.
Everybody can cry here, and we won't judge.
Okay, so let's stop crying for a bit and talk about something completely different. This week, I would like to talk about replacing the REPL of Python with the REPL of PyPy.
Exactly.
Because clearly we can do things like this, crazily somehow. Pablo, how can we replace the CPython REPL with a PyPy REPL?
So actually, the story is even funnier because indeed this is the REPL of PyPy, and we are talking about including it in CPython. But I've been told by Carl Borst. Oh man, I don't know how to pronounce this surname. I'm sorry, Carl, a lot. It's the other Carl. It's not this Carl.
That's Carl Friedrich Boltz.
Thank you very much, Lucas. And sorry, Carl, not from Cinder. So I'm making friends here. Anyway, so apparently I've been told that this was originally written by Michael Hudson Doyle, who used to be a Python core developer and stopped being active in 2006. But this is coming full circle. Like this started as a CPython kind of thing, and then it ended in PyPy, and now I'm bringing it back to CPython. And why we're doing that?
Well, because we need the extra triangle bracket in the prompt, obviously.
Right, this is a very niche feature. The REPL of PyPy has an extra angle bracket, so it's not like chevron is 3 chevrons, so it's PyPy and it has the power. Now we have the chances to confuse everybody and add a new one like 4, and they will see like, oh no, we are in a 5th. But anyway, so if you recall from our first episode, wow, I'm doing this super professionally, redirecting people to the first episode. In the first episode, we talked about the core developer sprint. And we were discussing among there like how to improve the user experience and whatnot. And I was talking with Lisandros in this project to try to have multi-line editing in CPython's REPL. So you finally don't need to press up arrow 6 million times in reverse order just because you make a typo in a stupid function, right? And then some people in PyPy were in the sprints and they saw me that PyPy actually does this, like as people do. Like this happens quite a lot. And I started to implement a new version for the CPython REPL that does this, which the REPL in CPython lives sadly in the parser, which is very annoying to modify because it's C and it's very dark C. And Antonio Cuni says like, no, just take the PyPy REPL. It has a very nice license and it works.
Yeah.
And so I changed a bit the approach, and I'm trying to incorporate the PyPy REPL into CPython, which turned to be a bit interesting challenge because PyPy REPL, it does, so it has a subset of the code that does the thing. So what you see in PyPy REPL, and it has multi-line editing, and it works 99% of the cases. But then it has this other part which I don't know if you can activate in PyPy, but it's there. Certainly, I don't know. That it looks like I don't know if you have seen this episode of The Simpsons when Homer Simpson designs a car. And it has all the features, so it has this hyperspace REPL, which is weird. When now you have this super funky prompt with weird Unicode characters. So it's not like the 3 chevrons. It's just this out of space thing. And when you do autocomplete, then it shows you a weird menu with weird magical effects. That is called actually fancy REPL inside the code base. So it's fancy REPL, and I stripped that out the first thing. I said nobody should know this secret. So I started to trim down the project quite a bit, and it works. But I think for CPython we need to change a bunch of things. And I using my seduction powers, I managed to trick Gukesh here. Wow, this is fantastic because now people will know that you say yes to this, Gukesh, and now you are obligated to comply. So we are going to, by the way, Lisandros as well is going to participate in this interesting endeavor. So we are going to try to port this module project refactored and massage it, as people say in the industry, into something that can be introduced in CPython, and hopefully in Python 3.13, where you can actually press up arrow and then the entire function appears and you can edit it multi-line. We live in the future. What do you think, Carol? Do you think this is something that you can use in Cinder? Now you can JIT the entire fancy
Sounds
REPL.
great. Does this also, the colors in the REPL, is this all the same PR, or is that a different thing?
Separate thing. Different.
Okay.
No, this is different. Spoilers.
Okay,
Spoilers.
sorry.
No, but he's right though, because he said colors in the REPL, which is, kind of the REPL itself can also be colored. Right?
But this is actually new because PyPy doesn't
Yeah,
have.
you should beep this out, but that's the thing that interests me the most.
No, but this has. Wait a second. We are not going to vendor pigment. Like I know how this goes. No, pigment is not going to be vendor in CPython, and we are not going to re-implement pigment. Like, look, if someone wants color in the repo, pip install IPython, and it works nicely, and
fair.
it has multi-line editing. It's fine. We just want. Like, look, there is a lot of people say, like, just use IPython. But, like, we've been told again and again that a lot of people that are learning Python, and, even us, like myself, I don't use IPython because I need to compile Python 3.13, and there is no IPython for Python 3.13. So I use the repo as well. And there is a lot of people, for instance, in VS Code and whatnot, that use the normal repo. So having multi-line editing is already a win. But we are not trying to do the Homer Simpson's car, right? Like it's just fancy enough, so it's cool. It doesn't get in the way. But if you want something, the latest model, just pip install IPython or VPython or one of these.
I mean, as someone
ones.
who compiles Python a lot on different machines in different places, and I'm just happy if like it finds readline and I can use the up arrow at all in the REPL. So these things you're talking about, this is just like beyond magic.
I'm very happy that you mentioned readline. So because this is one of the things that the Gukas here needs to deal with, because apparently the PyPy REPL. So this has a story that maybe we can invite the other Carl to explain. So apparently PyPy REPL reimplement the whole readline in Python because licensing.
Yes.
So now this REPL uses this half like readline written in Python, but like we don't really care about this because we have readline in Python. We have the licensing figured out. But now it's so entangled that we need to figure out how we can reuse the older readline in places. So that's something that Gukesh can help with, right? Gukesh, you're saying yes in front of all of our listeners, right?
Yeah, I'm nodding, so you don't have to beep me out.
Shit, but like
yes.
now I realize Gukesh is the one editing this podcast, so he can. And then, this strategy fail. I'm betting you that 313 new REPL plus colors is going to be the highlight.
Right.
I'm telling you now, like all the JIT hookers.
Of course.
No,
So it's going to be the
REPL plus
most
colors.
visible thing. Yes. Right. So like we're talking about plans, but there's plenty of things that already happened. So how about we talk about those for a bit?
Let's go.
What's going on in CPython?
So the most important thing that everybody needs to know, because that affects them right away, is that we've had new releases. So there's been Python 3.12.1 with 471 commits over Python 3.12.0. So that's over 120 bugs fixed. So if that sounds scary to you, you should know that, okay, yeah, it's a high number, but it's a lower number than 3.11.1 had over 3.11.0. So the trend isn't, getting more severe, but yes, there's a bunch of bug fixes that you want.
How do you feel about that comparison, Pablo, as the 3.11 release manager?
Yeah, well, I think that 3.11, this clearly shows that 3.11 is the best version because we have more commits, and everybody knows that is doing enterprise metrics. That means nothing, that more commits is better. So, like 3.11 is more robust, it has more commits. And you could say that, how many of these commits are actually introducing bugs and not fixing them. That's an interesting aspect, Carl, but we have to jump to this other thing here in this list of things that change, which is actually 3.11.7 got released. And you will say, oh, that's kind of cool because, there is this new bug fix version. I don't have fancy statistics on how many bug fixes. A lot, because 3.11 is the best release. So all the bugs are fixed in 3.11.7. The biggest feature here is that I forgot to actually announce it. I did the release, but I didn't announce it. So I'm fixing this a bit myself. I will do the announcement after recording the podcast, the official one. But I'm announcing it here as well. It's now released. Just go and get it because all the bugs are fixed in that version. That's the one that you want.
This is what essentially caused a bunch of people to ping me somehow, even though I'm not the release manager of that Python version. And that was because Dead Snakes was not updated for 3.11.7 and people panicked. Anthony Solisle just got them used to being updated on the day of a release of Python. So I talked to Anthony and I said, hey, if you need any help with this, I am part of the release team, so I will know when those happen every time. So I can help you actually push the green button, and see what happens. So he actually let me push the green button. So the Dead Snakes for 3.11.7 that some of you are going to use is actually produced by the finger on my trackpad back in Poland, in Poznań. So I'm going to be helping Anthony with that from now on. And since I'm already talking, and I've been kind of involved in this a bit, there is a large fix this time around for shared memory users. So shared memory is this kind of best kept secret for multiprocessing and async IO. So obviously nice that we're going to have now sub-interpreters being able to share immutable objects, and great that we're going to have a version of Python that is free-threaded. But for users of Python that already needed to share large data between processes, shared memory was an option for a bunch of releases of Python now. There's been some issues with how it dealt with the process being shut down. So it too eagerly tried to clean up after itself, meaning it would also destroy the shared memory segment, which might still be actually in use by somebody else. So there was an open bug for a long time now. I think it was since 2019 or so, where it wasn't quite clear what to do, because any change would be an API change, which is essentially a feature, but the behavior that we had was buggy. So finally, after a few attempted PRs that weren't quite ready, we actually got to a solution, which I'm very happy about. It was unclear which way to go, and finally, Pan324, I don't know who that is, but like a person on GitHub authored a change that actually is a feature now. So we now have a new track parameter on shared memory objects in multiprocessing, such that you decide whether they're going to be tracked and cleaned up after by Python when the process is shut down or not. So that got a ton of review by Gregory Smith, Guido, and Antoine Petrou. So now that's a new feature for Python 3.13. And we're going to get more sane behavior for shared memory users, myself included, so I'm happy to see this.
That's actually awesome. I have now an interesting story. So the actual thing that changed is that so fine-grained error locations, that's the error locations that you got from PEP 657, which is the one that has these squiggles under the lines that to tell you exactly where the error happened. Now work with multi-line expressions. So you have a function call that formatted with some famous formatter, maybe monocolor formatter. So you can now it will tell you the entire function or the entire expression. So the interesting story about this, and I need to shout out to the author of the change, which is William Wen from the PyTorch team. Probably works with Carl and Meta, if I'm not mistaken about the framework. So this person, which is a hero, the reason being is that he proposed the change because they apparently implemented a version of this on PyTorch. I don't know exactly why they needed to re-implement it, but he did. And he found a bunch of interesting edge cases that we fixed independently. But the interesting part that he proposed is to make it work across multiple lines if your expression had multiple lines. And at the time, we had two main areas of CPython when this change needs to happen. One of them was the traceback module, which is written in Python, the one that you can use to programmatically get tracebacks. But the other was the real traceback machinery that was written in C, and it's very ugly C, and it's very dangerous C. And this person made both changes, make this ginormous, gigantic PR with changes in traceback.py, new tests, updated tests, and a huge amount of SQL, thousands, almost lines of SQL, if not more. And that was a lot. It was a very difficult PR to review. I was very close to reject the PR because it was it's a lot of code for the feature, right? So the maintenance cost was super low. And then at the core developer sprint, I changed in Python 3.13 how this whole thing works, and I removed all this functionality from traceback.c, and now we're using traceback.py for everything. So just the Python code, and the C code is only for a backup. So in case something weird goes wrong, we can still print the error, even if traceback.py is not working nicely. So I went to this person, to William, and I say, cool, now all your C code is not needed, thanks. And the guy was the person was really, really nice. He actually refactored everything and rebased his change on top of the changes in 13, just to change the traceback.py. And he did mention how painful it was to write all that C code that disappeared. But he survived a bunch of reviews from me and Lisandras. and we merged the change, which is fantastic. The code is actually very good, and it works. He actually even implemented some edge cases when the lines, like you have a function that spawns like, I don't know, 15 lines. So, we skip the ones in the middle. We say like, oh, a lot of lines here, right? So 7 more lines. And like we saw the actual end and the start. So it's very nice. It's not going to eat all your screen just because it happens. So very nice feature, and again, shout out to William Wen from the PyTorch team for surviving the review and throwing thousands of lines of C code.
So we talked about editing lines a bit, right? And about the fact that there's a readline library, and that library has a weird license. Well, that weird license obviously is
GPL license.
yes, which is why PyPy re-implemented the entire thing. But there are other approaches to this, right? So BSDs traditionally ship with something equivalent called libedit, which is BSD licensed. So Python does allow you to replace readline with libedit if this is what happens to be available on your system. Only that if you do this, weird things start happening. So like most things behave correctly, the most tested, the easiest things that most people will try on their first interaction with a REPL, with some sort of line that they're editing, right? But there's more advanced use cases like tab completion that just stop working. And it turns out this is not because libedit doesn't support them. It's simply because it just expects a little bit different behavior. For example, it's not really tab completion. It's I think Control-I or something on the on libedit. So we've had a patch that was ironically kind of motivated by Homebrew on macOS switching over to libedit for Python 3.11. Kind of suddenly, and discovering that certain features in the REPL stopped working that people depended on before, like tab completion. So now Konstantin Hong wrote a patch to allow libedit to also support tab completion for us, and Peter Victorin and Tian Gao reviewed this. This is now landed. So while the core of the change might be simple, coming up with it and testing all the variants of the different libraries isn't. So this is some of the valuable changes that allow you, the Python user, to use Python regardless of what underlying libraries are available on your system.
That's quite cool. We mentioned black before, which is the code formatter, but talking about colors, but technically black is not a color, right? It's the absence of colors, whatnot. Very negative. But talking about color, I did this cool change that added colors to tracebacks, which is cool because now when you have a traceback because something went wrong in Python, you are now sad and desperate because your thing doesn't work. Now you can be a bit less sad because there is colors in the traceback, and because this is literally a bike 7PR, right? Because everybody had opinions.
Yes,
I'm also colorblind, which makes the whole thing even weirder because my opinions are the worst ones. So I very happily let everyone have opinions, and we discovered many stupid things. Like for instance, obviously this is not stupid, this is very important. Like people were concerned about like the colors need to work on light mode and dark mode, and that's very important. We believe about accessibility and we care quite a lot. But we also discovered that no color works correctly in dark mode and light mode at the same time. That's the way it is. There is some benchmark somewhere where you can test if the contrast is high enough, and not a single color from the ANSI codes 16 bits work in both modes. So we had to make some compromises. And you can change them, as Gukas is just waiting just to say that you can change them in your terminal. So you can say, Gukas, just say.
Yeah, so you can change them, but also that there are environment variables to control them, right? And they have precedence rules. So obviously, this is going to be a very often visited page of the documentation, because this is always something that people love when there are 3 variables competing for the same behavior, and you have to know like which one actually is going to be chosen by Python.
There is 6 million of them. There is no color, PyColors, force color, and there is one more.
No, now is the our one, which is Python colors actually,
Python
because
colors, right?
we didn't take pi_color because this is the one that PyTest is using, and
Jesus.
because that is different. This is different software. People might want to have different behavior between one and the other. Plus, we only recently adopted the policy of using underscores in environment variables of Python, but still they all traditionally start with the word Python. There are no that start with Py. There's always Python. So I was bike shedding that part more than the colors, because I love the colors actually. They are synthwave colors. They're amazing. They look great, kind of, you can just imagine just driving with your 1980, Ferrari into a sunset in California on the one every time you see an exception.
When you have an error, right?
Yes, exactly.
So yes, that went really well, and we have it there. I cannot wait for everybody to ask me to add APIs to configure the colors. No, that's the answer. Well, we'll see. But yes, colors now, and I will be even more colors in the future. But for now, just in traceback.
Yeah, very cool. One change that is maybe less relevant to the users, but extremely relevant to the developers of Python and as well to the downstream distributors, so for Linux maintainers and so on, is that it turns out ever since Python 3.0, there was a bug in regression tests that caused module reloading after a test and unit test was executed to not work correctly. So it was essentially ineffective. So now Serhii Storchaka, after essentially 20 years of this being buggy, looked at this and he was like, well, I'm just going to remove this because I don't understand why it's there, but it's not doing anything.
That never sounds well.
So this started this entire discussion of like, how about you don't remove it because maybe there was a reason why it was there, and in the end it's now fixed. So now you can actually successfully run tests with any random order, since like ironically the alphabetical order of test cases in regression tests was lucky in certain cases, right, where it was fine. But if you had a randomized order of execution within that same process, right, so those sequentially run tests without any workers, there were unlucky cases where you could just have crashes, where you have weird behavior. So you just reran the tests and they were fine. So now at least one big reason why that was happening is gone. That's like module reloading. So that is awesome.
That's cool. But do you know what is cooler?
What's cool?
SBOMs. Yeah, but only if you work in companies, because if you're a regular user, probably you don't care about this. But like, this is a word that I'm hearing all the time around me. Everybody talks about SBOMs. It's also a very funny name. So apparently it stands for Software Bill of Materials, which sounds very legal. But yeah, apparently it's very important. In particular, I think the US government per the... No, sorry, wrong thing. Sorry. The US government per the
Executive Order of the Department of Commerce.
So is required. Sorry, this is very serious. No, wait. It's required now that we have this.
We need to restart.
No, leave this. No, this is fantastic. Leave this. This is a whole podcast. Anyway, okay, so this is serious because apparently, like these SBOMs that sounds like very ominous. So this is like a bunch of information that you can record when you have like software like CPython, and this will basically include how a CPython was built. So CPython depends on a bunch of libraries, and we use those libraries depend on more libraries. So at the end, if there is like a security problem, or you want to know who are you depending on for different purposes, or just to track all the dependencies, but this is basically a security concern. So you want to say, okay, give me everything that CPython is depending on with all the versions, and you can start doing your research. And this is like the SBOM. And Seth Michael, which is our security developer in Resident, added a new makefile target because it's called make regen SBOM that will create these files. It will regenerate the file, and I will help track the software bill of materials for CPython. And this is in a specific JSON file, which I think is called SBOM SPDX, which contains this information.
Yeah, it's a
JSON
standardized format. So like other automation can read it and know immediately, like what we depend on, which is just kind of the point there.
Thank you.
Very cool. Very cool. Another thing that is pretty cool, I helped review and actually land in Python, which caused the 3.12.1 release to be delayed by 2 days. So, kind of compromises, is the fact that arrays in C types couldn't be returned by value on ARM platforms. And, kind of the reason why was it turned out that on ARM, structs with up to 4 elements can be passed through registers if they're floats, right? But because floats can be big, like that can be up until 32 bytes. So this is not something that C types allowed. So now Diego Russo from ARM fixed this. And it turns out that this actually helps also Apple, right? So Apple Silicon was one of those affected platforms. So that is very cool. So we had this change. We tested the change. I ran them on BuildBots. And then Diego was like, okay, cool. I actually need to add new tests for this so that we know that it's actually doing what we want. So there's more tests now. We landed the change and BuildBots broke on PowerPC 64 little Endian machines, because it turned out that the new test that Diego added afterwards also revealed that this particular thing didn't work on PowerPC as well. And we simply didn't know before because there were no tests for this particular case. So C types hides endless joy for people wanting to, test it on more or less popular architectures. So ARM is not going to be less popular anymore, I guess, right? Like it might essentially become more dominant in the future, which is essentially why I was a little surprised to hear that the Cinderjet is x86 only. Like, is ARM coming for this? Not
in the near term. I don't know what the future might hold.
Right. Interesting. In large companies, you don't really develop on your own laptop and whatnot, but kind of for...
We don't talk about that.
I was talking about this pretty publicly, for years, that it's pretty sweet to have your development being entirely remote. Now I'm not in this situation, since the remote would essentially mean my rack in my basement, so there's no point. So I ran on my Mac, and behavior might be different in C types and a bunch of other less utilized parts of Python. So now we have this fixed. The new test postponed the 3.12.1 release, which is now fine. We're good. Sorry for that if you're one of the Linux maintainers that were waiting, but at least now we know everything is good. To be clear, PowerPC 64 LE is not fixed just yet, but at least we are now properly skipping the test.
Skipping the test. This is exactly what you want to. That's very proper. This is because you forgot about the law of the universe that says that only one alternative non-Intel platform that Apple has used can work at the same time. So you have to choose either ARM or it's PowerPC, and we choose the best winner. Sorry, PowerPC.
So an advantage of remote development, the other week I flew for work to Menlo Park and I left my work laptop sitting on my desk at home. But since all the development is remote, I just got a loaner laptop, installed a few pieces of software, and I was off and running. Had no work in progress.
Oh, so what you mean is that you don't need a laptop at all, so you can return that one.
Right.
That's what your company will learn if you say that.
So you mean to tell me you don't need to remap caps lock to control?
Oh, that's one of the things I had to do with the loaner. I mean, there was a little setup. Yes, of course.
Okay. I was a little afraid for a second there. That we couldn't be friends anymore because, who uses caps lock as the caps lock? It's just...
Carabiner Elements is software number
Mental
one
sanity is important. Gukesh.
Exactly.
No, it's not. It's not just remap caps lock to control. It's remap caps lock to control when held and escape when tapped.
Oh, yes. I see you're a man of culture as well.
Everybody's like, what is these people talking about? You need to work for big companies to know. Or maybe not.
No, you just need to use
but
Vim.
talking about...
Or Emacs, or anything.
I use Beam.
Where is your escape key, Pablo?
Mask off. I use Beam. I use Beam, and I hate those people that change the caps lock to escape. I find this an abomination. The key is supposed to light when you press it. And escape is not a... You're changing a key who's creation demanded that is a multi-state kind of thing, right? And you're making it you're removing that from the stupid keyboard. Like, actually, if you do that change, it doesn't light anymore. You remove the life from the key. Like, I never use this key at all, but I like that, like poke, and there is this little LED now in my keyboard that just started to be like blue. It's beautiful blue because I use the key. And now if I remap it to escape, I cannot use the key. It's horrendous. Do you know what I use as escape? Listen, I use as escape the combination of the letters JK, one after the other. So when I'm in insert mode and I do JK, is escape. And you will say, why would you do that? Well, because it's in the home row. I don't need to move my hand all over the escape key, which is very far, or even to stretch that pinky over the caps lock. And there is no word in English or Spanish that has that combination. So it's very unlikely that you will ever need to type JK.
If you like the light on the caps lock key so much, there are keyboards you can get where every key has its own light, and you can just configure them to do all kinds of things.
I had one of those, but they're very obnoxious. I don't like them.
So how many times do you have to press JK to actually do Control C?
Just one. So you are writing, Gukas is not a trustworthy person, and then you do JK, and that's it. That's your normal mode.
That sounds horrible, but maybe I'll try it and see if I change my mind.
More changes. So Mark Shannon did some changes to the interpreter generator. So this is the script that generates all the things that we discussed in the previous episode. Wow, man, I'm looking like a professional podcast host. Like, I'm referring other episodes like it's nothing. So in the previous episode, we talked about the interpreter loop, and we talk about how now it's generated. So this is the script I'm referring to. Mark Shannon made one of these Mark Shannon 1,000 lines of change PR. To all good changes, I swear. And so all these changes are basically separating, parsing, analysis, and code generator on this script, which is good because normally when you do code generation, it's like having a mini compiler on the thing. So having these steps separated makes it more maintainable and less fragile. It's quite a large change. But it took a while, but Guido and Alex, I think, reviewed that and need it as well. And now it's merged, and therefore the script is much better and more maintainable.
Yeah, very cool.
Thank you, Mark.
Yeah, thanks. So let's just close off with some changes to free threading. So the so-called no-GAL, but don't call it that, free threading.
No, the Steam Council is listening.
Oh, yes, exactly. So they're going to beep me out if I say again. Free threading. So _pi thread ID merged in October by Sam Gross is a bunch of platform-specific inline assembly that we have in Python. Yes, so those are instructions to get the platform's unique thread identifier. So now, thanks to Donkey Na, this is now also supported on PowerPC that we all love, and S390X, which we love even more. Popular platforms, maybe not, but now this is supported for them, which is important because we will be able to run free-threaded tests on them now.
But Gukas, why do we need this inline assembly if you can always call pthread self? What's wrong with pthread self, Gukas?
Maybe we don't want this because we don't want any function call for this.
Exactly, dingo. Yes, that's it. Most people were saying like, why isn't blah, blah, blah. Actually, I tried this thing in Memray because we do the same thing. We get like thread-specific things, and it does nothing because we already will inline in pthread self. So.
Interesting.
But yes, you answered correctly. You won.
Cool. So I can keep my job for another month.
Do you have a sound effect for that?
So in any case, speaking of Donkey, he also added @getter annotation to argument clinic. You might have noticed, like in previous episodes, I also can refer to previous episodes. See, like I mentioned the new critical section API that we have now to make things thread safe. But for certain cases, this API was a little verbose because you have to do this all the time for any getter. So now Argument Clinic will generate this usage of the critical section API for you if you just create a getter for an attribute and so on and so on. So like this is very cool because it makes our boilerplate shorter for development of Python, so it looks more regular. We don't have to, kind of focus on the implementation details when we're trying to look at the logic. So I like this a lot. And it's already used in String.io, so you can look at that code and see whether you like it better or not. I like it better. It's much shorter.
Nice.
And a bunch of things were made thread safe, in fact, like, Unicode name, C API hash, D2A, and a bunch of others that I now forget. But yeah, like plenty of activity with free threading. People keep asking me like, oh, is the GIL gone yet? So like, no, it's not. But what I learned recently, now that I started actually poking at dead snakes, is that you can add the PPA that is dead snakes nightly. And when you install Python from there, you can install Python 3.13-NoGIL.
No, the illegal name.
The forbidden word. But if you use the
word.
forbidden word, you're going to get an interpreter that is that branch and is that configure flag, which is free threaded. So by the time we actually lose the GIL, like, you're going to have a free threaded Python. Nowadays, it's not free threaded yet, but plenty of the changes that only land in those ifdefs for free threading, you're going to be one of the few people who are actually exercising them right now.
Congratulations. And that's, I think, everything we had.
Right. Cool. Carl, thanks for coming to our janky little podcast.
It was great. Thank you. I'm counting on your editing to make my answers sound smart. So.
But it's also the last episode from the year, right? So it can be extra goodies.
Correct. Let's say this is why this was extra long. Tomorrow I'm leaving for Bangkok. I'm going to be keynoting PyCon Thailand, where I'm going to be spending the rest of the year. I hope you have a wonderful rest of the year as well. See you next time.
See you next time.